Now that we understand how to find the velocity, we should be ready to derive a formula for the force on each electron in terms of the velocity. So let's try. Let's go back to our equation for the force on the rod. F is equal to VIL. So this is the force on the whole rod, and as I explained in the last few videos, it is the resultant force on all of the free electrons that are flowing through this rod. Okay, and we had that number of electrons, if you recall. Right, I don't have to write down that number for this part. I'll just remind myself that there's this idea of the number of free electrons in the rod, which I call big N, and I want to find the force on each electron. So if I imagine looking at, say, a single electron, a single free electron that is moving with this average velocity of v, which I also found in the last video, I want to know what's the force acting on this one electron. So there would be a tiny force acting on this tiny charge, which I call little f. Okay, so little f is just the force on that single electron. And we know that if we know the total force on all the free electrons, and we know the number of electrons, the force on a single electron, would just be total force divided by the total number. Okay, so let me bring this formula in and write out the full expression. So that's what we have. Now I want to try and relate this formula to the velocity. Now we need to use the ideas from the last video. So there are one or two things I need to bring in. First of all, the current. Now you recall from the last video that current, which is charge over time, is equal to. Now in the last video I talked about how we can think of this time in this example as the time needed for electrons to flow in, for enough electrons to flow in and fill this rod, which is the same as the time taken for the electrons to move over this distance of L. Okay. So if that's the time, if time is the time taken to move over this distance L, let me write this out just here. It is equal to time for a free electron to move let's say over L meters. Then the charge would be the total charge of the free electrons in the rod, which would be the number of these electrons times the charge of one electron. and E. So this is what we understood in the last video. So let's press on with this. Now, so following from this equation then, I know that I is equal to NE over T. And so let me substitute this into here. I'm going to write this out. Write this out again. So F is equal to BIL over N. So let me rearrange this a little bit. I'm going to move the I to one side here. And then I'm going to substitute this into the I here. BL over N times NE over T. That's what I get. Notice that there is an N here and an N here, so the N cancel. So we don't actually need to know the value of N for this step. Okay. Now then the next thing I need is to relate this to the velocity. Since L is the distance moved by the electron and T is the time taken, so therefore we know that the velocity is equal to L over T, distance over time. And you see, I have a distance and I have a time here, right? So I can rearrange that. So F is equal to, if I rearrange this, I get B and E. Let me move B and E to one side, and then I have L over T on this side. So this is the same as this, and therefore, since L over T is V, I get B E V, and this is the equation. F equals to B E V. Let me write this out. This is a useful and important equation. It is the equation, the formula for the force on a single charge particle. So in this case, on the single electron moving with a velocity v. So just as an example of how we could use this, let's say I want to use this to calculate a force. I would need to know the field, the charge, and the velocity. Now, if you recall from the last video, the velocity that was calculated in the last video was a very small value. Let me write it out here. V is equal to, let's try and squeeze it in here, 7.36 times 10 to the minus 6 meters per second. That's what I got from the last video. So let me now find a value for this force on a single electron. V is 0.1 Tesla. E is the charge of one electron. That's 1.6 times 10 to the power of minus 19. And V is this value here, 7.36 times 10 to the power of minus 6. Therefore, using a calculator, we can find the force of a single electron, and the answer is 1.18 times 10 to the power of minus 25 Newton. And if you look back at, I think maybe 2 videos ago, you'll find that in that video, I've calculated the force on each particle by each electron by finding the total force and dividing it by the number of electrons. Right? If you look back at this video, you'll find that I got the same answer there. So in this case, I can just find the force on each electron if we know the velocity of the electron.